Okay, guys, this is number 2. So area volume. Okay, so we are given the enclosed area. This is R. So this one is enclosed by root of cosine x and then e to the x. And then you have to determine which one is a e to the x and the root of cosine x. And since this one is passing through the 1, so which means a maximum of the graph is a 1, right? So we know the bottom function is a root of cosine x. So we know this one is a root of cosine x. The upper function is a e to the x. We know that is a the exponential function. And then this vertical line is a pi over 2. All right, this is a pi over 2. Okay, so this one was a non-calculated section, but some of you use a calculator to figure out B. But on the AP exam, you're going to be really, really careful. You're going to read the direction. But I double check the problem, but it doesn't say anything if it's a calculator, non-calculated section. So yeah, sorry about that. But on the actual AP exam, you need to check if this one is a calculated, non-calculated section. All right, so this is non-calculated section. How do we know? Because it says right, do not evaluate. So here is a clue. So which means that this is non-calculated section. All right, so let's find out the area. So the area, we have two options, either top minus bottom in terms of x, right minus left in terms of y. But in this case, if you use the right minus left, the right function is always pi over 2, but you need to separate the boundary, isn't it? And then you have to solve for x. How can you solve for x? To use the right minus left. It's not impossible, but you have to use a cosine inverse to solve for y, to solve for x, right? So which one is better? You do better use a top minus bottom, because if you draw the vertical line, top function is always e to the x, bottom function is always cosine, root of cosine x. Now the area is a top minus bottom, top e to the x minus bottom, root of cosine x. This one is in terms of x. We need an x boundary 0, 2. This one is a pi over 2. So 0, 2, pi over 2. That's it. So this is a 2 points, limit, boundary 1 point, integrand, that's the 1 point. Now, this one is a volume, so now this one is a going around the x-axis, isn't it? All right. So if you're going around the x-axis, if you go over this function over x-axis, we know there is a hollow, isn't it? Okay. So we can use a washer. So the washer, the volume is a integral, so which is a pi integral outer radius square minus inner radius square. Since this one is going around this way, we know this one is a outer radius. So then top minus bottom, e to the x minus 0. So e to the x minus 0, that's the outer radius. Inner radius, which is a hollow, top minus bottom, which is a root of cosine x minus 0. We know this one is in terms of x because the radius is determined by the top minus bottom. So we need an x boundary 0 to pi over 2. All right. Now, it says a find out the volume. And then some of you put that in the calculator and they got the answer. Yeah, this one is not calculation section. So then pi, we need to evaluate this. So if you distribute the exponents, that is a e to the 2x. But a lot of your antiderivative was 2 times e to the 2x. But this one isn't an antiderivative, so you have to flip it. So which is a 1/2 e to the 2x. We know this one is a cosine x, but what is a antiderivative of cosine? Isn't it sine? So minus sine x. Bounded by 0 to pi over 2. All right, now plug in pi. We have a 1/2 e to the 2 times pi over 2, which is a pi, minus sine pi over 2 minus, plug in 0. If you plug in 0, e to the 0, which is a 1, times 1/2, which is 1/2. And if you plug in a 0, that's the 0. Okay, so now we have a pi 1/2 e to the pi sine pi over 2. We know that's a 1. So 1 minus 1/2, which is a negative 3/2. So that's the answer of the volume. Okay, now the C, this one is a cross section. So semicircle, how we can find the cross section, the semicircle. So isn't it the cross section? What was the cross section? So first of all, think about the area of a circle. Area of a circle, isn't it pi times, isn't it the radius square? Right? But since this one is a semicircle, we're going to divide by 2. Okay? So then we have to find out the radius. All right? So this one is the perpendicular to the x-axis. So this one is a perpendicular to the x-axis. So you have to draw that. So this is a diameter. This is a diameter, isn't it? But we don't need a diameter. So this distance between the top minus bottom gives us what? The diameter of a semicircle. So how it looks like? It looks like this. Okay, this is a diameter. But we need a radius, right? So top minus bottom and divided by 2, that's the radius. So the diameter is a top minus bottom, e to the x minus root of cosine x. This is a diameter. But we need a radius, e to the x minus cosine of root of x and divided by 2. So that's the radius. And then you have to plug in. So now the cross section is a pi over 2 integral radius square. So that's the radius. Plug in e to the x minus root of cosine x and over 2. And square top minus bottom in terms of x boundary 0 to pi over 2. So that's the volume of, that's the volume of a cross section.